Okay, so this is section B. They are saying calculate the entropy change of the system at 298 Kelvin. Include a sign and units in your answer. Of course, the formula for entropy is product minus reactant. Sum of all the entropies of the product minus sum of all the entropies of the reactant. So we have to apply the formula. So then we will be getting the answer that is going to be 185.6 joules per Kelvin per mole. That's the unit for like the entropy change, okay? And of the system, because the formula for surrounding is different. That is minus delta H upon T. We have two formulae for entropy change, system and then surrounding. And sometimes they ask the total entropy, so we would be adding the two values like system plus surrounding is equal to the delta S of total. So they have given you the value for 6H2O, they have given you the value for cobalt chloride, they have given you the value for H2O. What I did, we are supposed to multiply the value for water by 6 because the coefficient is 6. And that's what I did, then I got 185.6. State whether the sign of your answer in A part 1 is as expected from the equation for the reaction. Justify your answer. You can see I'm getting the positive answer. I am getting the positive answer. It means that the entropy is going to be positive or entropy is increasing. So they are asking justify this positive answer with the given equation. And if you remember, if we have more randomness, so the entropy is higher. And if we have less randomness, so the entropy is lower. So you can see in reaction side, I have 1 mole. This is 1 mole. And in product side, I have 6 plus 1, 7 moles. So you can see in the product, we have more moles. So what I did, there are more moles which have higher entropy. Okay. So there are more number of moles, I can say. uh In the product side, I have more number of moles, okay, which have higher entropy, means that they have a higher randomness, okay, or I can say disorderness. Then they are asking about the entropy of the surrounding. Of course, now I'm going to apply this formula delta H upon T. So surrounding is, they have given you the value for delta H, that is 88.1 kilojoules. Kilojoules, remember. And we are going to calculate the entropy, and they have given you the temperature as well, that is 29 to 98 Kelvin. So the formula is this 88.1 divided by 298 Kelvin. So you got the answer of entropy, that is in kilojoules per mole per Kelvin. You may also convert this unit into joules per mole. Okay. So then in that case, you will be getting the answer in joules per mole per Kelvin. So it's up to you whether you can convert the unit or not. Okay. State whether or not the decomposition is feasible at 298 Kelvin. Justify your answer. Like you can see, this was the entropy of system and this was the entropy of surrounding. Okay, that is negative. So if the total entropy is positive, so the reaction is spontaneous or I can say feasible. And if the total entropy is negative, so the reaction is not feasible or I can say non-spontaneous. Okay. So so as you can see, I'm getting the total entropy answer that is going to be negative. You can see total entropy would be negative, right? So not feasible because the total entropy change is negative. Okay. So that's why they were saying whether or not it may be feasible, it may not be feasible. Completely, it is depending upon the entropy answer. Okay. Okay. Then calculate the lowest temperature in Kelvin at which the thermal decomposition of hydrated cobalt chloride becomes feasible. So I would be applying this formula delta G is equal to delta H minus T delta S. I have to calculate the temperature. as they are saying that the reaction is feasible, becomes feasible. So the delta G should be equal to 0. Okay, so T delta S would be equal to delta H. I have to calculate the temperature. It's gonna be delta H upon delta S. I have the value for delta H, that was 88.1, and this is the entropy of the this one, entropy of the system, 185.6. What I did, I have converted this into the joules. You know why? Because like in kilojoules, because the unit for delta H is kilojoules per mole, right? The unit for delta H is kilojoules per mole. So the unit for entropy should also be in kilojoules. That's why I have converted this unit and I got this answer. When you will be dividing these two values, you will be getting the temperature, that is 474 Kelvin. That's your answer. Simple. Bronsted and Lowry defined acids and bases in terms of the transfer of a proton between two species. Write the equation which shows how a compound HA can act as a acid then when dissolved in water. State symbols are not required. Okay, so let's say HA is an acid and it's going to donate a proton according to the Lowry-Bronsted theory. So when HA is dissolved in water, so it gives H positive ion to this water. So water becomes H3O positive because it would be getting a proton, it would be getting hydrogen, and rest of the HA becomes A minus. That's the equation in which you can see HA is going to donate proton to this water. Okay, which shows that compound HA can act as a Bronsted-Lowry acid, since we know the definition of Bronsted-Lowry acid, that is a proton donor. Okay, so and in part two, they are saying when HA dissolves in water, okay, give the mathematical expression. So this is the formula for pH. pH is equal to negative log of H positive ion. Negative log means, inversely proportional. Negative log means inversely proportional. Then give the mathematical expression used to calculate the concentration of H positive ion. I have derived this expression from this one. If you remember, Ka was equal to the concentration of H positive square divided by the concentration of ethanoic acid, that is CH3COOH. Then what I did, I'm going to make a subject. H plus square is equal to Ka multiplied by the concentration of acid. I'm going to take square root of this. So I would be getting this answer. Okay. So they were asking direct relation. So I did this. You can show your working for yourself. Calculate the pH of an aqueous solution of 0.25 mole per dm cube ethanoic acid. Since this is a weak acid, so I can't say that I can't take a mole ratio between acid and H positive ion. Let's suppose sometime they gave you the concentration of HCl, and then what we did, since the ratio is 1:1 between HCl and the concentration of H positive ion, so we say that the concentration of HCl is equal to the concentration of H positive ion. But we can't do for the weak acids because they are not 100% dissociated. They partially dissociate, if you know. So of course we have to apply this formula first, because for the pH we need to know the concentration of H positive ion. So I'm going to apply this relation since they have given you the Ka value and the concentration of acid is also given. So I have just put it in this formula. I got the concentration of H positive ion in mole per decimeter cube, and then after putting this value in the pH formula, I got 2.6795. That's your answer. Then they are saying the effect on pH of changing the concentration of the two acids are different. This is Hydrochloric acid, it's a very strong acid, and this is ethanoic acid, it's a weak acid. Point 0.1 to 0.01, then 0.01 to 0.001. You can see the change in pH. It's changing from 1 to 2, 2 to 3. And it's changing from 2.88 to 3.38, 3.38 to 3.388. You can see this is a minor difference. To explain this difference, no further calculations are required. Since we know that HCl is a stronger acid than ethanoic acid. And we know that HCl fully ionizes. Remember, so if you will be increasing the concentration of HCl, so it means that you are going to increase the concentration of H positive ion because they fully dissociate, 100% dissociate, or near to, like we can say 99% dissociate, near to 100% dissociation. So if you are increasing the concentration of acid, means that ultimately the concentration of H positive ion increases. And when the concentration of H positive ion increases, so of course the pH would be increasing. So we can see the relation, how much the pH is going to be increased. You can see like how much the concentration is increasing. So I did this one and I got that it is going to increase by a factor of 10. By a factor of 10. So the concentration of H positive ion will also decrease by a factor of 10, isn't it? Because you know pH is equal to the negative log of H positive ion. When the pH increases, it's mean that the concentration of H positive ion should decrease, because I told you they are inversely proportional to each other. You know, pH is going to increase. You know, it's mean that acid becomes weaker because it's going to near to 7. When pH is far from 7, so the acid is stronger. When the pH is near to 7, so the acid is weaker. Okay. While when you are changing the concentration of ethanoic acid, that partially ionizes, so of course you can see pH is higher than HCl. Okay, like if it is 1, it is 2.88. This is 2, this is 3.38, this is 3, this is 3 point. The pH is higher than HCl. So as it does not fully ionizes, so decreasing the concentration is decreasing. So decreasing the concentration is not having the major effect on the change in pH. You know what's the reason? It's one and only reason, means that I can say weak acid partially ionizes. So we can say that the mole ratio between acid and H positive ion would not be the same. That's the reason. Okay. So, okay. Marmalades are food stuff made from citrus fruit. Okay. Uh, which contain the weak acid, which contain the weak acid. So citric acid, sodium citrate, the sodium salt of, okay, suggest the benefit of adding sodium citrate to the marmalade. You know, if you remember about a buffer solution, if you remember about a buffer solution, okay, so you know, buffer is prepared by the reaction of weak acid and its salt. If you remember, buffer solutions are prepared by the addition of weak acid and its salt. Okay, so citric acid is a weak acid and sodium citrate is a salt of that weak acid. So you can see citric acid and sodium citrate forms a buffer solution which maintains the pH, which is changed by fungal activity. Okay, so that's the benefit. That's the benefit. So the buffer solution is prepared and which is going to maintain the pH of a food stuff. Of course, okay. Uh, okay. Yeah. State the overall order of this reaction. So I would say the order of this reaction is 2. Okay. because this is 1 and this is 1. So the overall order is 2. Or the procedure demonstrates the effect of changing the concentration of iodine on the reaction rate. State why propanol and hydrochloric acid are in a large excess compared to iodine. Remember, when something is in a large excess, remember when something is in a large excess, okay? So if you will be changing the concentration, if you will be changing the concentration of that substances, that species, so the rate of reaction will not be affected because they are in a large excess, you know. So what I have written, concentration of propane and HCl will not affect the rate of reaction because they are in a large excess. Explain how the results could be used to demonstrate that the order with respect to iodine is zero. If you remember, we used to learn that whenever in a zero order reaction, when we decrease or increase the concentration, so the rate doesn't change. It means that the reaction is going to be zero order. That's why that's why the rate is not changing. For a first order, when the concentration is doubled, so the rate is doubled. For a second order reaction, when the concentration is doubled, so the rate increases by 4. But for a zero order reaction, when the concentration is doubled or tripled or 4 times or 8 times, but the rate is not going to change, means that this is going to be zero order reaction. So explain how the results could be used to demonstrate that the order with respect to iodine is zero. Plot a graph of volume of thiosulfate. You can see volume of thiosulfate, because you know, if you can read this whole para, so they are saying zero point 0.1 mole of propanol and zero point 0.01 mole of HCl in a total volume of 90 cm cube of water were placed in a flask at a constant temperature. Then this much mole of iodine in 10 cm cube of water was added and a timer is started. Simultaneously, a 10 cm cube sample of solution was withdrawn. Like I have taken away 10 cm cube of sample. The sample was neutralized using excess sodium hydrogen carbonate like NaHCO3. At 10-minute intervals, further 10 cm cube of the mixture were withdrawn and neutralized by adding sodium hydrogen carbonate solution. All the samples were titrated with sodium thiosulfate solution. So that's why I have taken this, the volume of sodium thiosulfate. Okay. So plot a graph of volume of thiosulfate against time. Against time. Okay. So of course, they have told you the reaction is going to be zero order. The condition is given. So we have to explain accordingly because we know the order. Because we know the order. If you remember, for a zero order reaction, the gradient is equal to zero. Let's suppose if the line is like that. If the line is like that, you are going to find out the gradient. You are going to find out the gradient. So of course the gradient is constant because the line is straight. When the gradient is constant, so means that the reaction is going to be zero order reaction. That's why it's of 2 marks. It's very easy. Because the condition is given. That's the important thing in this question. Condition is given. Okay, so we have to explain accordingly. Sodium hydrogen carbonate is used to neutralize the acid. Okay, write an ionic equation. We knew this one from the previous classes, basic classes. If you remember from IGCSE or GCSE, like whenever we have bicarbonate, hydrogen carbonate, HCO3 minus, and you know that this is a base because it contains carbonate ions. It's going to react with acid. Acid is represented by H positive ion. It would be giving you CO2 and water. Rest of the things you can fully write down the equation first. Okay, like that. I'm taking HCl, so I would be getting NaCl plus CO2 plus water. Now you can cancel out this. So this is aqueous. This is aqueous. This is aqueous. This is gas. This is liquid. Cancelled. No, 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 no. Sodium, sodium cancel. Cl, Cl cancel. I got CO3 minus. H plus, CO2, and then water. That's why. That's why, right? Give a reason why sodium hydroxide cannot be used to neutralize the acid in this experiment. You know, if you will be using sodium hydroxide, if you remember from organic chemistry, if you remember from organic chemistry, so in organic chemistry, we used to do iodoform test, if you remember. And interestingly, in this question, I have propanol. You know, what's the formula for propanol? CH3, C double O, C double bond O, CH3. If you will be adding sodium hydroxide, so, it will react with iodine and it would form a iodoform with this reactant. So to avoid this, we are not supposed to use sodium hydroxide. We are not supposed to use sodium hydroxide. That's why we are using other than this. That is sodium bicarbonate. Okay. It's also a base. The rate of reaction is first order with respect to HCl. Okay. They told you. Describe without giving experimental detail how you would show that this was due to the hydrogen ion. It's very easy. If you remember, when we used to solve like the table questions like that, if you remember, experiment one, experiment three, and this is the concentration, this is the concentration, this is the concentration, this is going to be 0.03, this is going to be 0.03, or this is going to be 0.05, this is the rate, 2 exponent minus 3, 3 exponent minus 3, 4 exponent minus 3. Okay, so this was due to H positive ion, this was due to, let's say, Cl negative ion, this was the rate. So what we used to do, let's suppose if I am going to find out the order of reaction with respect to H positive ion, so I have to take experiment 1 and 2. If you are thinking why, because this is going to be constant. This is going to be constant, so I can study the effect on changing the concentration, effect of changing the concentration on the rate. This is going to be constant so that it might not affect your relation. Okay, so so the concentration is doubled. So you have to see rate is doubled. Yes, rate is also doubled. Means this is going to be first order. So they are saying without giving experimental detail, you have to show. Okay, so that's it. Repeat an experiment in which concentration of Cl minus changes, then compare the results to show that they are same. Okay, repeat an experiment in which the concentration of Cl minus changes. Like to make sure whether the rate is changing only due to the Cl minus. So what you have to do, you have to change the concentration of Cl minus and then you have to see whether the rate is changing or not. If the rate is changing, so you can say the rate was changing due to the concentration of Cl minus. And if you can see the rate remains same, so yes, the rate is not affected by the concentration of HCl. So that's the best method to check whether the rate is depending on the concentration of HCl or not. That's it. Okay. What they are asking in this question, explain why the rate determining a step must be step 1 or step 2 but cannot be step 3. So, rate determining a step is a slower step. If you remember, rate determining step is a slower step. And we know that the slower step is the one in which the bond is being broken down. Isn't it? Isn't it? The slower step is the one in which the bond is being broken down. Okay, because the bond formation is a faster step. Bond formation is a faster step. So I would say that in step 1, you can see like the bond is being broken down. Or in step 2, you can see the bond is being broken down. Okay, this one I'm talking about, this one. Okay, so um, they were saying in this, Explain why the rate determining step must be step 1 or step 2 but cannot be step 3, because in step 1 and 2 contains propane which is in the rate equation. Or also we know that also in a given rate equation, you can see this is going to be propanon. This is going to be propanon. So propanon is involved in a rate equation. So I can say, you can say, you know that the rate equation is only written for the slower step. If something is in the rate equation, so means that that is going to be the slower step. Otherwise, why did we write down the rate equation? Of course. So CH3COCH3, this is propanon. This is propanon. So that's why I told that step 1 and 2 contains propane. Like it's not propane, it's a propanon. It's a propanon, right? Which is in the rate equation. That's it. Suggest a reason why step 2 is the rate determining step rather than step 1. So you can say, you can say in step 2, now you can analyze these two steps, step 1 and then step 2. Uh, what's going on in these two steps? Okay, you can see this is step number 2 and this is step number 1. You can see the carbon carbon double bond in step 2. You can see the carbon carbon double bond and the bond of CH is broken down. You can analyze these two steps, by the way. CH3, 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 CH3. You can see, like in this bond is going to be broken down. And we know that the bond energy for CH is very high. So a lot of energy is required. So on the basis of this, I can say that this would be the slower step. So I only mentioned that step 2 involves breaking of a strong bond. So it is a rate determining step, and this is the slower step. Okay. So by the way, in this you have to know like which bond is stronger and which bond is weaker. So CH bond is stronger bond. Give the IUPAC name for compound Q. Compound Q means that I have started from the right hand side because we have a ketone, we have OH, both are functional groups, so they are going to be preferred. So this is 1, 2, 3, 4, 5. So 1 hydroxy, and you can see 4 methyl. Okay, 1 hydroxy, 4 methyl pentane, 2 on. This is a ketone, that's why they have on. Ketone means on, aldehyde means al, and alcohol means all. So they are called suffix. They are called suffix. So we have to use these suffixes on the basis of a given functional group. Explain why the carbon 13 NMR spectra of compound P and Q cannot be used to distinguish between. So if you can see the chemical environments, they have the same chemical environments, like they're asking carbon 13 environment. So 1, 1, they are the same environment. Then this is the same. Okay, this is going to be 3, this is going to be 4, this is going to be 5. So it has total 5 chemical environments. If you can see this one, 1, 2, 3, 4, then 5. Okay, again, I would say that it's going to be 5 chemical environments. So that's why I cannot distinguish on the basis of carbon 13 NMR spectrum. The high resolution proton NMR spectrum of compound P contains uh, 4 peaks, while that of compound Q contains 5 peaks. Okay. So peak A, the chemical shift for peak A is 1.3, then for B is this, then this, then this, then this. Relative peak area. You can see for compound P contain 4 peaks, while that of compound Q contain 5 peaks. Some data for compound P are shown. Let me check the compound P. Okay. Let me show you the relative areas. This is going to be 3. This is going to be 2. This is going to be 3. Like this is going to be 6, by the way, because they are having the same environment. So this is going to be 6 and this is going to be 1. 3, 2, 6, 1. 3, 2, 6, 1. 3, 2, 6, 1. So I did the same thing. Singlet, 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 singlet. I would be getting the singlet. If you're thinking why, because there is no neighbor hydrogen. There is no neighbor hydrogen on this carbon. So I would be getting singlet. I also would be getting what about this one? What about this one? What about this one? And also, no. Sorry. No. This is what I would be getting singlet. This is OH negative ion. This is OH negative ion. Okay. So I got the singlet. You can see singlet. And also for this carbon, like for CH3, I'm talking about the carbon towards which these two groups are attached has no hydrogen. Again, I would be getting the singlet. Again, I would be getting the singlet. And for this CH3, no neighboring hydrogens are there. Again, I would be getting the singlet. So I would be getting total 3 singlets. One for this, one for this, and one for this. For this singlet, the relative area is 3. For this singlet, the relative area is 6. For this singlet, the relative area is 1. And what about this CH2? What about this CH2? If you can see this CH2, so the neighboring carbons are 2, 1 and then 2. Is there any hydrogen which is attached to these carbon? No. So again, I would be getting the singlet. So all are singlets, but the relative peak area is different. Relative peak area means the total number of hydrogens. It's going to be 3, it's going to be 2, it's going to be 6, it's going to be 1. So that's why I have quoted the same numbers. And now the very important thing is to know it's of, I think, how many marks? 2. And then C is, okay, 2. Okay. So, okay. So I have to see the data booklet as well, you know. I have to see the data booklet as well, by the way. On the basis of that, I have quoted the numbers. That's it. Okay, so some data for compound Q are shown, and they have basically mentioned the carbon atoms as well, you know, hydrogen. So B is for this one, C is for this one, C is for this one, or then the remaining hydrogens are this one and this one. So the OH would be singlet. It's gonna be 3.8. It has a higher shift because this is OH negative group, like this is an alcohol group. So the chemical shift would be higher, and the remaining one would be this one. The chemical shift for these two CH3s are lower. That is 1.3. Okay. Now they are asking about compound Q. So if you can see compound Q, they have mentioned all the alphabets. This is Z, this is Y, this is X, this is W, this is V, this is V. So, you know, V means that they have the same chemical environments. Or you can see the W, then you can see X, then you can see Y, then you can see Z. So, okay. So for Z, it's going to be split. Relative peak area is 1 because you have only one hydrogen. And for CH2, it has two hydrogen atoms. Okay, it has two hydrogen atoms. So for Y, I also would be getting the singlet. So the relative peak area is 2 because I have two hydrogen atoms. Or for this CH2, this is going to be X. You can see on the neighbor carbon, it has only one hydrogen atom. So I would be applying the rule that is N plus 1 rule. So 1 plus 1. It would be getting the doublet. And there are two hydrogen atom in this one. So that's why it is 2. Then if you are getting W, so for W, how many hydrogen atoms, neighboring hydrogen atoms basically, two on the right hand side and three on the left hand side. So 2 plus 3 is 5. According to this rule, it's going to be 6. So that's why they have mentioned it's multiplet. Okay. And this carbon hydrogen has only one hydrogen atom. So the relative peak area is 1. Or if you can see V has total 6 hydrogen atoms. So the relative peak area would be 6. And these two CH3 groups, I have only one hydrogen atom. So I can say I would be getting doublet, 1 plus 1. Okay. So that's why I have mentioned that this is doublet. Okay. Now